Polarization and pitting. Electrochemical polarization is the potential shift away from the open circuit potential of a corrosion system due to the current flow. There are three types of polarization, which are activation polarization, concentration polarization, and ohmic polarization. Activation polarization is caused by overcoming the energy barrier of the slowest step of the electrochemical reaction. It is controlled by the reaction sequence at the metal electrolyte interface. Concentration polarization occurs when there is a concentration change of reactants or products near the electrode surface. It is controlled by the diffusion gradient in the electrolyte. Ohmic polarization describes the potential drop due to the high resistance of electrolyte solution or across the surface films. Polarization can occur at both cathode and anode. Anodic polarization occurs when the potential shift in the positive direction, above corrosion potential, whereas cathodic polarization occurs when the potential shift in the negative direction, below corrosion potential. Potentiodynamic is a polarization technique that is used for corrosion testing. The three electrode setup is used to study the effect of potential and current on the sample. The potential difference is measured between the working electrode and reference electrode. The current is measured between the working electrode and counter electrode. In a polarization curve or Tafel plot, the anodic slope is above the corrosion potential and cathodic slope is below it. The intercept of the two tangents can provide us with a corrosion rate and linear polarization resistance by using Stern-Geary equation, whereby the greater the polarization resistance, the more resistant towards corrosion. Passivation involves a shielding outer layer of corrosion. The layer may occur spontaneously in nature through self-passivating, or can be introduced as a micro-coating. A typical polarization graph shows the corrosion rate of different stages of passivation. Passivation occurs when an oxide layer forms a continuous film on metal surface, preventing further oxidation. Under a clean, controlled environment, repassivation will occur after the breakdown of the oxide layer. However, in the presence of chloride ions such as from sodium chloride electrolyte, pit initiation and propagation will occur instead. Conditions of pitting formations are breakdown of the passivation film or other surface defects, presence of halogen ions such as chloride and bromide ions, and stagnancy of electrolyte. High temperature, acidic solutions, presence of surface deposits would also promote the formation of pitting. The critical pit potential is the least positive potential at which pits can form. Below critical pit potential, no pitting will occur. Pitting will only occur at and above the critical pit potential. Its value is dependent on chloride concentration. For a given chloride concentration, the more positive the critical pitting potential, the more resistant to pit initiation. Critical pitting potentials are usually determined from steady-state anodic polarization curves as shown. Based on the graph, when pitting corrosion initiates at critical pit potential, it will propagate rapidly. That's all from us, thank you for watching.